All right. Now the first question says, what can be used as an expression to find out what A is? And A is going to be this triangle right here. The best way to go about doing this is to figure out what the sine of A is, the cosine of A is, and then the tangent of A. So if you figure out those three things, here's A. What side is that? Opposite or adjacent? Opposite. This side right here is going to be adjacent, and this side is hypotenuse. So you need to know your SOHCAHTOA. Opposite, the sine is opposite over hypotenuse, so it's 4/5. This is going to be 3/5 because it's adjacent, and then this is going to be 4/3. So now we take a look at these. What this says is, in order to get to A, it's got to be the sine of that 4/5. Is the sine 4/5? No, it's 3/5. It doesn't help us. It's not going to get us the right angle. It's actually going to get us angle B. Now, the cosine is 3/5, and it says 0.8, but 3/5 in decimal form is 0.6. So is 0.6 equal to 0.8? No, that doesn't work. Now, the tangent is 4/3, so the inverse tangent should be up 4/3. Which one is it? D. So D works for that one. All right, next one, number 2. Which is not equivalent to the cosine of 60 degrees? Well, do you remember that the cosine of A is equal to the sine of B? You guys remember that? So A plus B is equal to 90 degrees, because those are these two angles right here. A plus B, that has to be equal to 90 degrees. So if you have the cosine of 60 degrees, this should be equal to the sine of 90 minus 60, which is 30. Is there a sine of 30 degrees?
Yeah.
Absolutely. So remember this, A plus B equals 90, cosine A equals sine of B. No, they're not the same. If you plug them in the calculator, you'll get two totally different things. All right. Now, number 3 says the sine is 5/13. What's the cosine and what's the tangent? Now, the sine is opposite over hypotenuse. So, what's the opposite side? 5. And what's the hypotenuse? 13. Now, how can we figure out this last side? Well, you can look at all the answers, and what's the other number? 12. So I'm pretty sure that's a 12, but there is a Pythagorean triple that says 5, 12, 13. That's a special type of triangle, so that's a 12. But you could have also used 5 squared plus x squared is equal to 13 squared, and you would have got x equals 12 in that case. But since 12 is popping up on every single one, we're going to be in business here. Now, what's the cosine of x? What's the adjacent side of x? 12. What's the hypotenuse? 13. So the cosine has to be 12/13, which means that guy's gone and that guy's gone. Now the tangent of x has to be the opposite side. What's the opposite side? 5. Adjacent side is 12. So I need 5/12. That's my A. So you could use Pythagorean theorem, but remember, sine, you got to be able to identify opposite side. You got to be able to identify all the adjacent side, the tangent, or the hypotenuse, and everything. All right. Now it says the sine of A is 0.07. what is the length of AC? So I want that guy right there. What is that? Is that opposite, adjacent, or hypotenuse? Hypotenuse. Now, we're talking about A, so there's a sine of A. What's 21? Okay, that's opposite. So I could say that the sine of A is equal to the opposite, which is 21 over x. But do I know what the sine of A is? Yeah, it's 0.7. So 0.7 is equal to 21 over x. So I multiply 0.7 times x is equal to 21. Now I'm going to divide by 7/10. Now why did I say 7/10? Yeah, that's the decimal in a fraction. And since I don't have a calculator here, I want to do things kind of quickly. I'm just going to say, all right, I got to divide this by 7 over 10, which means 21 times 10 over 7. 7 divides into 21. How many 3 times? 3. 3 times 10 is 30, so this is equal to 30. Is there one of them that's 30? Yeah, C, right off the bat. Now, if you have a calculator, are you going to dump it into a calculator probably? I would say yeah. You'll probably dump it in a calculator. There's no harm in doing that. It's just, I'm a professional. Which means, the better you get with the numbers, the better you are. Alright, now it says, how many feet tall is the street light? So there's the H. There's 40. What side is that? Opposite. What side is this? Adjacent. Which one? Sine, cosine, or tangent? Alright, so the tangent of 40 degrees is equal to the opposite side, which is H, over the tangent side, which is 20. Multiply both sides by 20. And now I got to plug it in. So I'm going to get 20 times the tangent of 40, and then I got to find the degree symbol, put that in there, so 40 degrees looks like 16.782 feet. So remember that you have to put everything in degrees if you're working in degrees. We're working in degrees. So you have to find the degree symbol. There's 3 places you could do it. You could do it next to the H. There's a fancy key next to the H that has it. There's a fancy key next to the the G that has it. Or you can go control book and find it. Well, 4 is it's a side length. So it's not a degree. Just because I had to type it into the calculator. In problem 4, I didn't have to type in anything as far as a degree goes because it was 0.7. I knew the answer was already 0.7. So I didn't have to type in sine of an angle because I already knew what the answer was. Yes? Your phone actually has a scientific calculator that has sine, cosine, and tangent on it. Yep. You usually have to hit this. There's a second button. And it's kind of like the control button on this calculator. It'll take you to another set of commands.
And that's on, like when you turn it to the side, that's on there.
Yeah, and you hit second, and bam, all of a sudden the inverse ones pop up there. It's usually in degrees to start with. All right. Write the equation that gives the correct value of BC. All right, calm down. Now, is this opposite, adjacent, or... Yeah, it's opposite. There's adjacent. So, set up, in this case, set up all three of them. Just set them up really quick. Opposite is going to be BC over 10.6. So look for the sign. Is there a sign that says BC over 10.6 for the sine of 32? No, that's sine of 58, so B is gone. Now the cosine of 32 is going to be 8.2 over 10.6. Is there BC at all in there? No, so I'm not going to use that one. So it looks like I'm going to use the tangent. And the tangent of 32 says I'm going to use BC over 8.2. Now, the sine one didn't work. The cosine one didn't work. Well, we just eliminated all of them, so you can just circle C. But here's the thing. Remember that the tangent of A is equal to is equal to 1 over the tangent of B. So if you take 90 minus 32, you get 58 degrees. And so basically you're looking at this one right here, 58 degrees. The tangent would be the opposite side of 58, which is 8.2, over the adjacent side, which is BC. So that's kind of the reason why that one works for you. But the nice thing is you could also have eliminated a bunch of them. One. It's just a 1. I'll set these up, but I won't solve them. A surveyor 50 meters from the base of a cliff. So here's a cliff. Surveyor's over here. There's 50 feet. Angle of elevation to the top of the cliff is 72. How high is the cliff? That's an X. Well, I got 72. Is that opposite or adjacent? Opposite. What's this guy? Adjacent. So we're going to use the tangent of 72 degrees. It's going to be equal to the opposite side, which is X over 50, and then just solve for X. So like I said, set up but don't solve. You guys can solve it. You just got to multiply by 50, you're done. 50 times the tangent, you're all good to go. Alright, the Grand Canyon. Point at North Rim of Grand Canyon, a surveyor measures angle of depression to a point on the South Rim. From the aerial photograph, he determines the horizontal distance between the 2 points is 10 miles. So he's here. And there's a South Rim. 10 miles is between them. And the angle of depression is 1 degree. 1 degree, and that's right here. 1 degree. From the distance is 10 miles. So when I draw the triangle, which is going to be like this is going to be 10 miles. How many feet from the South Rim below the north rim is the to the nearest foot. So I need to figure out this guy right here. Now, if this is 90 degrees, I take 1 degree away, this is 88 degrees. 89 degrees, you're right. I have opposite and adjacent, so I can say that the tangent of 89 degrees is equal to 10 over x. So x is equal to 10 divided by the tangent. I'm going to do this one for you. 89 degrees. So 10 divided by the tangent of 89 degrees and I got 0.174551 miles. Now it says, all right, 1 mile is 5,280 feet. So I'm going to multiply that by 5,280 feet. And it says that x is equal to 921.63 feet. So you're almost 1,000 feet above the floor. I multiplied by this, 5,280. Alright, this next problem. 125 feet from the base of the building. So this is 125 feet. To the third floor, which is right here, the angle of elevation is 22 degrees. So that's 22 degrees. This angle of elevation is 53 degrees. And it says, how much higher is the 10th floor from the 4th floor? So if I figure out x, and then I figure out y from the big one, because basically I have two triangles. That's 125, 22, and x. And then I have 125, I have 53, and y. And this is going to get me to the 3rd floor. This is going to get me to the 10th floor. And that's going to give me those two values. Now, I have opposite and adjacent again. So what are we using? Yeah, tangent of 22 is equal to x over 125. Here the tangent of 53 is equal to y over 125. So basically, x is equal to 125 times the tangent of 22 degrees. Here, y is equal to 125 times the tangent of 53 degrees. So x is going to be equal to something, y is going to be equal to something. Pull out your calculator. 125, no, we don't want to do that, no. No. 125 times tangent of 22 degrees .50 feet. So to get to the 3rd floor, it's 50 feet high, 50 and a half feet high. Now we do 125 times the tangent of 53 degrees Now, that's going to get me to the 10th floor, and it says, what's the difference? That's what I say, what's the difference? So 165.881 minus 50.50, 183,511. So there's your difference. 115.381 feet. That's the difference between the two of them. So, what was that? No, it's in feet. It's going to be difficult to see these. That works a little bit better. All right. What's the ratio? What's equivalent to the sine of z? Sine of z is equal to, ladies and gentlemen, you're talking too much. What's the opposite side from z? 7. What's the hypotenuse? 25. So I need 7 over 25. In that case, it's b. Yeah, for that one, yeah. For that one, all you have to do is set it up. And now for part 2, we're going to use the same triangle. I want to figure out what the tangent of x is. Tangent of x is opposite over adjacent. So what's the opposite of x? Alright, so it's going to be 24. What's the adjacent? So it's 24 over 7, which is d. Alright. You guys are going to have a tough time tomorrow if you keep talking. Highlighting has a tendency to bring out information. That's the only reason why I do it. When it's light, it's like that. Alright, it says, what's the length of altitude FH? So FH is right here. Forms a right angle. That's an 8. That's an 8. Now, what do you think it's going to do to this segment? That's 8 and 8. What's it going to do? Yep, going to cut it in half. 4 and 4. And we want to figure out what this value x is. Say that again? Well, this whole thing would be 8, but x isn't necessarily going to be 8. Now, it says find the angles first, but ladies and gentlemen, do I really need to find the angles if I know that's a right angle? I have 4 and an 8. What theorem can I use? Pythagorean theorem. A squared plus b squared equals c squared. Now, one of the legs is 4, so it'll be 4 squared, plus x squared, which is the second leg, is equal to 8 squared. So that's 16 plus x squared is equal to 64. Subtract 16. X squared is equal to 48. X is going to be equal to the square root of 48. Now, I know 48 is 16 times 3, so this is 4 times the square root of 3. And you don't get an even number from it, but 4 times the square root of 3 is the exact value. Yeah. Yeah, you will. That's what it would be. All right, last but not least, last page. All right, we need the triangle of XYT right here. We need to figure out the area. Now, in order to figure out the area, we need to figure out x and y. And we can do that based on what we got. Figure out the sine of 60. It's y over 12, isn't it? So y should be equal to 12 times the sine of 60. Figure out the cosine of 60. Should be x over 12, right? Multiply both sides by 12. Get 12 times the cosine of 60 is equal to x. Now, since this is a right triangle and the diagonals intersect a rhombus at a right angle, the area of a right triangle is equal to 1/2 leg 1 times leg 2. So the area is going to be equal to 12 times the sine of 60 times 12 times the cosine of 60. So that's 144 times sine of 60 degrees times the cosine of 60 degrees. Now, this is going to be equal to 144 times square root of 3 over 2 times 1/2. That's just because I know what these are. 60 is a special angle. 2 goes into here, what, 72 times? Then 2 goes into there again, 36. So this is 36 times the square root of 3. So that's my area. And that's just saying that the sine of 60 is equal to the square root of 3 over 2. The cosine of 60 is equal to 1/2. Millions and millions and millions. A little bit of this, a little bit of that. Alright, in the rectangle, what's the length of the diagonal? I know that's a 5, so this is a 5. And I want to figure out what x is. Do I have enough information? Yep. Alright, is that opposite or adjacent? Adjacent. So I need the cosine of 60 degrees is equal to 5 over x. Now, if you type this into your calculator, your cosine of 60 is actually 1/2. And that's equal to 5 over x. Now, think of this as far as fraction goes. If this is a fraction that's equal to 1/2, 5 over what is equal to 1/2? 5 over 10. So x should be equal to 10. So you can use some mental math to do that. If you don't like that, x times 1, go x times 1 is equal to 2 times 5, so x is equal to 10.
Would you have been able to do like cos 60 times 5 to get the answer?
No, that would have given you a different answer. So you got to put the stuff in the right spot. Trigonometry is all about making sure that everything is going in its right spot, or else the answers are going to come out all messed up. So make sure that you're putting things in the right spot. 10 is the answer. Almost done. Alright, use these triangles. What must be true? Alright, they're similar. Which means this is 3 times x, this is 5 times x, and that's 4 times x. But we don't know what x is. So, it says, is the tangent of G equal to the tangent of L? Are they the same angles? Are they corresponding angles? Yeah. And if that's the case, then that has to be true. The tangents are going to be the same. That's the thing about similar triangles. The sine of one angle in one triangle is going to be equal to the sine of the corresponding angle in the other one. Since G and L are corresponding, sine G equals sine L, cosine G equals cosine L, and the tangent of G equals the tangent of L. Now G and M, G is up here, M's down there, they're not corresponding. H and I, H is here, and L is up there. They're not corresponding. H and M are corresponding, but that's a sine and a tangent. So that's no good, that's no good, that's no good. That is corresponding. And it has more to do with the fact that the angles are in the same location. Alright, so now it says, if G, the sine of G is 4/5, one thing I know for a fact that the sine of L should be 4/5, because G and L are corresponding angles. So their sines are going to be the same. Now, is there one that says sine of L is 4/5? D. So all the other ones are wrong. So use the fact about corresponding angles in similar triangles. They give you the same trig values. Because I looked at G and L, and in the triangle they're the same. I mean, if this one would blow up and be put right on top of the other one, G would be put on L. And so I know G lines up with L. And over here, also in the name, G lines up with L. So if you look at the name tells everything. G lines up with L. So those have to be the corresponding angles. Absolutely. Absolutely. Alright, now it says sine H is equal to 3/5. So there's H, the corresponding angle is M. So sine of M should be equal to 3/5. Is that there? No. Now here's the thing. It's not there, so that's not an answer. Sine of M, but here's another one of those rules. The sine of M is going to be equal to the cosine of L. So if the sine of M is 3/5, that has to be equal to the cosine of L. Is there a cosine of L that's 3/5? Yeah. And that comes from the fact that in any triangle, the cosine of A is equal to the sine of B. And that's just that whole idea that an opposite angle an opposite side becomes an adjacent side, and the adjacent side becomes the opposite side. The hypotenuse stay the same, so the cosine and the sines flip for the angles. Yes.